Hey everyone, and welcome to this session called The World is Asynchronous, an introduction to event APIs. My name is Linus Hakansson, and I'm the Senior Vice President of Product here at Gravity. So today, I'm going to start introducing what we mean by saying that the world is asynchronous. Then I will have a look at some of the survey results recently from Postman, where developers got asked about the API technologies that they use, and we're going to see if there's some trends there in terms of the different technologies. I'll then introduce a little bit more event APIs and how they are different in terms of how they communicate and behave compared to traditional type of APIs. We'll then just very, very quickly look at some of the event API standards or asynchronous standards out there, like AsyncAPI and CloudEvents, to see how they are similar and different and what problem they're looking to solve in this space. We'll then take a look at how API management platforms have kind of evolved over the years and how they are maybe emerging into event native API management to cater for this new world that is indeed asynchronous. We'll then have a look at a few examples of different patterns and where event APIs may help in exposing and controlling your data architecture. And in the end, we'll just do a very kind of simple walkthrough of what it will look like if I would be wanting to expose something like Kafka using something like webhooks as an example of such a pattern. So for those that are in love with technology and love to watch different conferences like this one, some of you may have attended, whether remotely or in person, the latest Amazon reInvent from 2022, where the CTO of Amazon, Werner Vogel, made this kind of introduction keynote where he had this amazing sketch of how the world would look like if it was not asynchronous. And it was not really a world that we recognize ourselves in. And he wanted to kind of paint a picture of how the world is asynchronous, how you get more real time and real value to customers by implementing things like event-driven architectures and providing real-time experiences. So if you haven't checked that one out, have a look. It's both very funny and also very informative. Now, every year, Postman do the state of the API reports to kind of look at how organizations and developers are using APIs, how important APIs are in the organization, what type of technologies they use, what gateway technologies they use, and so forth. One of the most interesting for me is looking at the most common architecture styles, Postman calls this, that developers are using. Now, REST have been trending downwards. It's still by far the leading one. I think 85, 86% of developers use REST, but it has been trending down. I think it was 93% just 2 years ago. Webhooks has been increasing. GraphQL has been increasing. It actually replaced SOAP in this year's survey results on the leaderboard there in the top 3. WebSocket is following, and we have other protocols like gRPC, MQTT, AMQP, server sent events, EDI, and EDA. So obviously a lot of different styles and messaging concepts here, but as you might pick out, quite a few of them are actually asynchronous. You have webhooks, you have in some ways GraphQL, you have WebSockets, in some ways gRPC, but then again MQTT, AMQP, and server sent events. So a very mixed bag of how organizations are starting to use more and more different types of styles of architecture, and how some of them, especially increasingly, is asynchronous. Now, obviously, for developers and for product managers and other architects and other roles, specifications and schemas are an important part of both traditional and event APIs. Now, JSON schema in the latest survey is still leading that kind of race. It's the most commonly known and most used specification, or in this case, a schema. And then you have Swagger and OpenAPI specification, which in some cases implements JSON schema as well, being very known and very well used. AsyncAPI you have somewhere there in the middle. It's still followed by GraphQL, or still follows, I should say, GraphQL and WSDL. I'm going to touch upon AsyncAPI as well in a bit, but you have other schemas like Protobuf and Avro, which is very much commonly used in different data and event-driven type of message world use cases. So what are some different concepts of traditional synchronous APIs and asynchronous APIs? So if we cover some of the traditional APIs and how they typically interact, they're typically synchronous, right? So someone makes a response, typically a client, and then the server or the API makes a response back to the client in a synchronous way, meaning that one request typically means one response back to that client. It's typically a point-to-point communication, meaning that one client initiates a dedicated communication with a server, and that server communicates only back to that client when the response is ready. Typically, it's using the OpenAPI specification or Swagger specification to demonstrate and document what this particular service and contract is supposed to look like. The data format is typically JSON and XML in most traditional APIs, and it's either something like REST or SOAP, or in some cases GraphQL is also commonly used on HTTP. Now, event-driven APIs are typically asynchronous, which means that one client might establish a connection to a server or a broker or an API, and then expect messages potentially flowing through back and forth, whether they are publishing or subscribing to a particular event. And not always is the communication point-to-point. It may instead be, for example, fan-out, that as soon as there's an update on the server side, it might actually send that out into multiple isolated consumers or clients out there. You can use OpenAPI specification in some regards, for example, when you're documenting webhook APIs, but typically you work with AsyncAPI, and then you can also look at something like CloudEvents to document and control how your event-driven APIs are supposed to work. The data formats are not always JSON and XML. They can be binary format, they can be plain format, they can be with things like serialization and deserialization with Avro, protobuf, and so forth. So much more flexibility in how event-driven APIs typically work on the data format. And there's a bunch of different technologies that are in this event-driven API category. You have WebSocket and servers and events. You have webhook, which we will be having a look at. You have obviously different event broker styles like Kafka, AMQP, MQTT, and so forth. And I'm also adding GraphQL here, as GraphQL has a particular operation called subscriptions that typically works on kind of with WebSocket and servers and events to stream updates to a client for a particular query. So just quickly on AsyncAPI and CloudEvents, as I think they're both very, very interesting. AsyncAPI, very similar to OpenAPI in the kind of semantics and the problem it's trying to solve, being the specification and documentation for event-driven APIs. It addresses the messages and payloads inside those events, working with things like JSON schema. It is protocol agnostic, so it doesn't care if it's Kafka, WebSocket, or whatever it might be. And it has a lot of schema flexibility and extensitivity. If you want to use another extended schema, work with stuff that are not JSON schema, that is something you can do with AsyncAPI. CloudEvents is also a specification for event-driven APIs. It also touches and addresses the payloads and messages. It is also protocol agnostic and can also be very much extended. So that's kind of the similarities. Where they differ is AsyncAPI really cares about the design time. So helping the developer to consume and produce messages, understanding what channels and operations they can use, understanding how to authenticate to the API, how to understand the relationship between producers and subscribers for a particular API. So very similar to some of the problems that OpenAPI have solved for traditional APIs. Now, CloudEvents really focuses on the runtime, what's actually happening when an event is being received or produced by an entity. And it aims to normalize the events to allow much more flexibility between producers and consumers. So for example, if you have an API that is a Kafka API, and you're developing a Node.js application that consumes messages, applies some business logic, and then all of a sudden, someone switches out Kafka against MQTT, you would have to rewrite a lot of your business logic because MQTT and Kafka messages do not follow the same message structure to iterate over the payload, for example. But using CloudEvents, you get that consistency and normalization so that a consumer will potentially never break if it's compliant with the CloudEvent specification. It doesn't cover security. It doesn't cover the real documentation of how the API is supposed to operate, how it's secured, what operations exist, and the relationship between producers and consumers is very much focused on that kind of runtime component and interoperability, and is more targeted to developers and architects, while OpenAPI and AsyncAPI is more for the owners of the events and the maybe API product managers and so forth that want to document and communicate about the concept of what their APIs are doing. So what does all of this mean for API management platforms? So the way we have seen the market evolve in terms of APIs and API platforms is the first wave of API platforms really went out to provide governance and security and centralization on top of all these APIs that have been created on top of SOAs and ESPs and ETLs and those type of architectures. It allowed a way for consumers to discover APIs, to subscribe to APIs. It allowed API providers to secure them, to provide traffic shaping, all these things that we kind of take for granted today. Then what happened a couple of, maybe I'd say 10 years or so, organizations started to break up large monolith applications and move them into microservices. They started to containerize them with things like Docker. They started to use Kubernetes platforms to kind of orchestrate how containers kind of work together and or load balance and autoscale and so forth. And with that came a lot of declarative approaches like GitOps, that you wanted to have a kind of infrastructure as code approach, that your source of truth for your actual application and your lifecycle is what is in a JSON or YAML file. Now, a lot of those architectural best practices and trends basically led a new generation of requirements for API platforms. You needed to work better with microservice APIs. You needed to work in Kubernetes, having ingress controllers, service meshes, operators in this kind of world. And that's kind of where a new wave of API platforms kind of emerged. I think around that time, also OpenAPI specification came about from Swagger, just from a specification perspective. And then AsyncAPI came a few years later, trying to address the event-driven architectures that were starting to emerge. Now, what we have seen when we talk to people, when we are at conferences and we speak to our customers, is people have started to adopt event-driven architectures. They start to see the value. They want to provide real-time experiences. They want to take real-time decisions. And so they're starting to implement these event-driven architectures. They might implement something like Kafka or Solace or MQTT or AMQP or Azure Event Hub or AWS Kinesis, whatever it might be. They typically start implementing this, and then they start looking at exposure with webhooks, service-sent events, WebSockets, different ways for developers to develop applications that are also kind of working asynchronously. Now, what we have seen happening is the same type of problems that vendors used to be able to address in terms of, documentation, developer portal, security, traffic shaping, rate limiting, all these things we've taken for granted for REST and SOAP APIs do not necessarily exist in the same way in this kind of event API world, where you don't have that consistent developer experience when you go to a developer portal to discover, find, and consume both traditional REST and SOAP APIs and GraphQL and Kafka and webhooks and so forth. And this is where we think there's a change in how API platforms are evolving. We call this event-native API management, meaning that you treat the event APIs and the asynchronous architecture and communication patterns with the same level as you treat the traditional APIs, with consistent documentation, whether it's OpenAPI or AsyncAPI, if you're using CloudEvents, if you're securing your APIs, if you're providing traffic shaping, monetization, API productification, all of those concepts we believe should be treated the same regardless of the architecture style of the API. So that's kind of the challenge a little bit today in the market, that traditionally API gateways, for example, mainly care about the REST and the SOAP and so forth, and do not necessarily care about the Kafkas and the Solace and the MQTTs of the world. So when you start to have use cases where you want to expose some of the event-driven architectures, maybe you want to notify your partner or end customer when a shipment has arrived, or you want to allow them to go and replay old messages from an event stream based on previous orders that they've done, for example. You start to wonder, how do I expose this data that may sit in my event brokers securely and safely and easily to my consumers? Because some consumers may want to still use REST APIs, but still want to access the data that sits in a broker. Some maybe want to have webhooks so that they can just subscribe to changes and have everything pushed to their servers when there's a change in the upstream. Some may want to use something like servers and events and WebSockets to build mobile apps and web apps against these kind of asynchronous services that might be backed by event brokers. So from a Gravity perspective, what we have seen a lot with our customers is different kind of mediation patterns and how to expose safely the event-driven architectures to the outside world or to internal consumers that may or may not have access or the technical ability to integrate directly with a broker. So one of those examples is exposing Kafka with HTTP, whether it's post to inject data into Kafka or retrieve data using GET. So what you can see here is basically what we provide as Gravity as an API management platform, the ability to have consumers injecting data into a gateway using HTTP post, and then for us to send that through to the right Kafka topic, for example. Another example would be if you want to subscribe to data as a consumer. Again, you might be developing a mobile app and you want to receive real-time stock ticker information. Now, you might need to subscribe to a gateway here, and then the gateway might get data from Kafka or MQTT or Solus or something, and then stream that over WebSocket to your application in real time. Now, obviously, with WebSocket, the communication can also be the other way around, where the client sends data to the gateway, and then the gateway sends to the upstream Kafka or whatever event broker may exist. Another very common method of exposing event data is using webhooks. So the power of webhooks is that it gives the control of the destination to the subscriber. So the subscriber can go to a developer portal and say, hey, oh, this data is exactly what I want. I want you to send me this data over here to my server as soon as it's available. And I only care if the temperature has reached 20 degrees or whatever filter you may want to have. Then, in our case, the gateway connects to whatever upstream event broker. As soon as there's a new message, it checks what consumers have subscribed using webhook, for example, applies any filtering or security mechanism, and then sends that across to the callback URLs and the servers of where the subscribers have pointed us to. So for Gravity Event Native API Management, it's about the flexibility as well for organizations to expose these event-driven architectures either synchronously or asynchronously. So on the left-hand side of my screen, you can kind of see the synchronous ways with SOAP and REST, whether it's injecting with HTTP post or getting it out with HTTP GET. Or on the right-hand side, you have things like WebSocket, webhook, servers, and events. Now, if you're an architect and you have something like Kafka, and your client or partner needs that in a particular format, you can simply just point to the Kafka and then with a click of a button say that, oh, my client needs this as a WebSocket API or a webhook API or service and events or maybe a REST API if they are using the Open API specification. So event native API management is about that flexibility and the treating event APIs as first-class citizen from the gateway all the way up to API productification, analytics, and developer experience. So I'm just going to go through a very quick example here to kind of illustrate what that can look like using something like Gravity. So in my case here, I'm having a Confluent Kafka broker. I'm pushing through an XML message into that particular topic. On the other hand, I have a developer that goes to a developer portal and subscribes to an API that indeed is going to fetch this data from Kafka. So they are going into the portal, they're finding this webhook API in this particular case. They're saying, yes, I want this sort of data and I want it sent here to my server. Then of course, someone needs to go in and approve that subscription as you would with those sort of use cases. But then once everything is approved, there will be a runtime flow that the gateway is controlling where any new message on the Kafka broker that has the right filter, has the right security based on the subscription might provide traffic shaping. So in our case, what we're doing is we might convert the XML message into JSON because maybe that's what the client needs it to look like as it's received on the server side for their application to work properly on the data. So to recap, anytime there's a new XML message on the Kafka, the server that the developer registered will receive that message in JSON in this particular case. So how to make that happen? Using something like Gravity, you would go in and create a new API. So in this case, I'm calling this my webhook API. I'm giving this a short description. And then I'm saying I want this API to be exposable as webhook. So I can actually select multiple so that my developer can choose whether they want to consume the data using HTTP GET or service and events or webhook or other type of measures. But in this case, I'm just selecting webhook. Then I can decide what my actual upstream source is. So beyond things like HTTP and SOAP, I can actually say here that, hey, my upstream is a Kafka broker. That's where the messages and the topics are gonna come from. So I can provide, in this case, I'm using Confluent with whatever security I have in the Confluent cloud, where the gateway will be connecting to. Then what I can do is I can apply policies on publish and subscribe phases. So publish and subscribe is similar to request and response, but this is the asynchronous world of the terminology, basically. So in the case of webhook, my API can only be subscribed to. So that's the only mechanism for webhook. If I were using WebSocket, I could apply traffic shaping maybe on the gateway for maybe the publish and subscribe phase. So in this particular case, I am saying that I want to transfer the message from JSON to XML. I think I got it the other wrong way in the slide deck, actually. So a message comes in as JSON in Kafka, and it's going to be converted to XML before it's sent out to the various registered callback URLs that have been registered by the applications. So I then expose that, and then my developer can go into the developer portal, can see all the synchronous and asynchronous APIs, subscribe to my webhook API here, in this case, view the documentation, make a subscription, putting in this particular case, the URL of where the gateway should send any updates to. So that's my callback server that I've entered right here, which is using a dummy webhook.site for demo purposes. And then once that application and subscription is approved, whenever I put a JSON message into a particular topic in my Confluent Kafka and I send that through, my webhook server, which is again dummied by this webhook.site, will receive the message as an XML document. So the gateway listened to changes on the broker, provided some traffic shaping, whether that is using converting to something like Avro or XML in this case, or doing rate limiting, or transforming the message in any shape or form. But in this case, I just apply that kind of XML transformation. So that's kind of a very short introduction to asynchronous communication, event APIs, some of the standards, some of the things we have observed as an API management provider in terms of how organizations are implementing event APIs, some of the patterns that they are exposing it in, and just a quick example of what Gravity can do to help in terms of exposing that sort of stuff safely and securely. So I'll now take any questions if there are. Well, I guess this is a live recording, so there won't be any questions, but thank you very much for listening in.